Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 4. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 14 says, in the 1930s, scientists investigated collision of alpha particles with protons to determine whether the collisions were elastic. The diagrams show an alpha particle before and after the collision with a stationary proton. The proton moves off at an angle theta to the original direction of the alpha particle. Before collision, alpha particle is moving and proton is at rest, and momentum of alpha particle before collision is given to us, and after collision this is the situation, and momentum of alpha particle after collision is also given to us. Part A says, show that the momentum of the proton after the collision is about 5 times 10 to minus 20 Newton seconds at an angle theta, where theta is about 20 degrees. This question is about momentum in 2 dimensions, and most of the time students they struggle with this type of questions. But this type of questions are quite straightforward one if you simply understand how to answer questions. When momentum is in 1 dimension, then you can also answer questions for momentum in 2 dimensions. So there is no big difference. If you're very confident how to answer questions about momentum in 1 dimension, you can also answer questions about momentum for 2 dimensions. You just need to be confident. When momentum is in 2 dimensions, there are little more steps. But when momentum is in 1 dimension, there are fewer steps. That's only difference. Method is 100% is the same. Now let's try to answer this question. So first of all we will discuss how to approach this problem, and then we will plug in numbers and we will find the right answer. So first thing you need to understand, for any closed system, so we can say for any closed system, momentum before means the total momentum of the system before collision has to be equal to total momentum of the system after collision. So this is the first thing we need to understand. Now we can break down this momentum before into 2 components. We can say momentum along x-axis means along horizontal, and momentum along vertical. And we can also break down this one into 2 dimensions, momentum along x-axis and momentum along y-axis. So we can write down this equation again. So we can say momentum along x-axis before collision has to be equal to momentum along x-axis after collision, and momentum along y-axis before collision has to be equal to momentum along y-axis after collision. So this is how we can break down. Now we need to understand momentum along x-axis before collision. Before collision we have only alpha particle that was moving along x-axis, and proton was at rest. So simply we can say in this case momentum before collision is only momentum of alpha particle. So we can write on here momentum of alpha particle before. This has to be equal to momentum of alpha particle after, because after alpha particle is moving along this direction, it has 2 components. So we can use arrow for that. It has 1 component along x-axis and it has 1 component along y-axis. And proton also has 2 components. It has 1 component along x-axis and it has 1 component along y-axis. So after collision we have momentum of alpha particle along x-axis plus we have momentum of proton. For this question we need to calculate momentum of proton, so we need to find out momentum of proton after. It has to be equal to momentum of alpha particle before. So we will be writing B here for before, minus it has to be momentum of alpha particle after. So we can say A after. Now simply we need to plug in values here. We can find the x component of momentum of proton, and from here initial momentum along y direction is equal to 0. So from here we can say that momentum of alpha particle along y direction after plus momentum of proton along y direction, it has to be sum has to be equal to 0. So we can simply say it means that momentum of alpha particle has to be equal to momentum of proton along y direction, but the direction will be opposite. So this means direction is opposite. So if you're saying this is a vector, this is a vector, here will be negative sign. If you're just talking about magnitude, it means the magnitude will be the same. So here we have this point. This equation I'll be writing here. So momentum of proton after, we can say momentum proton after Klein is equal to momentum of alpha particle before, so we can write on in detail before, minus momentum of alpha particle after Klein. So we can find out x component, we can find out y component, and then we can find out the momentum. So we will go to that point later. Now first of all, we have momentum of alpha particle before, and this is the value of that. So we can say this is value of that. So simply we can plug in here. This is 1.26 times 10 to minus 19. This is before. And how we can find out momentum of alpha particle along x after. So here we have momentum of alpha particle after, and this is equal to 8.06 times 10 to minus 20, but we need x component. And so this one has to be equal to 8.06 times 10 to minus 20 cosine of this angle. We are talking about x component. Cosine of 10.2 degrees. So if we solve this one, we will find x component of proton. So if we solve this one, we will find x component of proton, and if we do this calculation, you will get 4.67 times 10 to minus 20 Newton seconds. So this is momentum of proton after. So we have found this one. So this is very important one. We need this one later. So we can draw rectangle around this one. Now y component we have discussed. These two components are the same. So we can say y component of proton after, this is equal to y component of alpha after. So we are talking about y component now. If you want to write down, you can say x component here for better understanding. We can also say here y component. So we are talking about y component. Like this you need to approach y component. I'm writing these things in detail so you can have better understanding of this concept. So next time you will not struggle with momentum in 2 dimensions. So how we can find the y component, mean this component b y. So this is simply momentum because this is sine. So we will write on here, this is 8.06 times 10 to minus 20 sine of this angle. This is 10.2. So we can clear this. So we have 10.2. Now if we solve this one, we will get the value. Y component we will get from here. Y component, that will be equal to 1.43 times 10 to minus 20 Newton seconds. So we have y component of momentum of proton, and we have x component, so we can calculate momentum. We need to calculate this one. So momentum of proton, simply we can say this will be equal to px square plus py square, means the momentum of the protons. We are talking about proton, and we have to take square root of this one. So x component we have, that is 4.67 times 10 to minus 20 square of this, plus we have 1.43 times 10 to minus 20, we have to square this value, and if you take the square root, we will get final value of momentum. That will be equal to 4.88 times 10 to minus 20 newtons second. And this answer is very close to this one. If you write down up to 2SF, 1SF, you will get this value. So it means this one is correct. Now we need to find out the angle. This angle we need to find out. So simply we have to take the vertical component. So we can say tangent of theta. This will be equal to the vertical component Py divided by Px. So theta from here will be equal to tangent inverse of Py. We have Py here. So this is 1.43 times 10 to minus 20 divided by, we have 4 point mean x component, 4.67 times 10 to minus 20 here. And if we solve this one, our angle will be about 17 degrees. So this answer is also close to 20 degrees because this is about 20 degrees. So this is our final answer. This is how you can approach a beautiful question. So the steps are, these are the steps. For any closed system, momentum before has to be equal to momentum after. This is a vector, means direction and magnitude before and after has to be the same. Then we can break down this one into two components, along x and along y. So along x it has to be the same, and along y momentum also has to be the same in magnitude and also in direction. Then we can resolve into components and we can figure out what we need to calculate. So this is the main method. I hope this makes sense to you. If this makes sense to you, please like and subscribe because your encouragement is very important. Part B says deduce whether the collision was elastic and mass of alpha particle is given to us. So first of all, we need to understand the condition for elastic collision. So the condition for elastic collision. For elastic collision, kinetic energy before, kinetic energy of the system before collision has to be equal to kinetic energy of the system after collision. So kinetic energy before means that we have only alpha particle. So the momentum of alpha particle, so we can say momentum of alpha particle square divided by 2 times mass of alpha particle before collision has to be equal to momentum of alpha particle square after collision divided by 2m, 2 times mass of alpha particle, plus it has to be equal to momentum of proton square divided by 2 times mass of proton. This is mass of alpha, this is mass of proton. Now we have masses of alpha particle and also proton, and also we have the momentum. So simply we need to plug in values. If these two equations are equal, it means it is elastic. If they are not equal, it means this is inelastic. So that's the main point we need to do. We have momentum of alpha particle before collision, that was equal to 1.26 times 10 to minus 19. So we have to square this value divided by 2 times mass of alpha particle, that is 6.64 times 10 to minus 27. And momentum of alpha particle after collision we have, that was equal to 8.06 times 10 to minus 20. We have to take square of this one divided by 2 times mass of alpha particle, means 6.64 times 10 to minus 27, plus momentum of proton. Momentum of proton we have just calculated, that was equal to 4.88 times 10 to minus 20 Newton second square divided by 2 times mass of alpha particle. Mass of alpha particle is 1.67 times 10 to minus 27. Now if we solve this one, we will get here 1.2 times 10 to minus 12 joules. This is 10 to minus 12 joules, so this is minus 12, and here we will also get 1.2 times 10 to minus 12 joules. As these two sides are equal, it means kinetic energy before is equal to kinetic energy after, so it is elastic collision. So simply we can say this is elastic clear. So this is how you need to answer. I hope it makes sense to you. This is very important one. You need to understand kinetic energy is equal to p square divided by 2 times m. P is the momentum and m is the mass of that particle. So this is momentum and this is the mass. So this is mass. So this is very important equation for some multiple choice questions and also for long question. You need this one. So you need to understand relationship between momentum and kinetic energy. Question 15 says the photograph shows a toy car inside a plastic ball. The car has an electric motor and follows a circular path in a vertical plane. The car travels at a constant speed. A student determined how the resultant vertical force on the car varied over a period of time. The graph shows the student's data. A positive value represents an upward force. For part A1, show that the angular velocity of the car's motion about the center of the ball is about 40 radians per second. We need to calculate angular velocity, means we need to calculate omega, and omega is equal to 2 pi over t. So if we have value of t, we can calculate angular velocity. Value of t we can read from here. So this is one complete cycle. So this is 0.15, so one small square, so this is 0.16. So time period is 0.16. You need to be careful with units. So this is in seconds. If we solve this one, we will get 39.3 radians per second. This question has 3 marks, and the 1 mark, if you have written t is equal to this one, you will get 1 mark, and if you have used this formula, you will get another mark, and if you have got the right answer, you will get another mark. Very straightforward question, and this question has 3 marks. Second part says the student took measurements of the ball and wrote down a value of 86 millimeters. Deduce whether 86 millimeter was the radius or diameter of the ball. Mass of car is equal to 9.5 gram. In order to answer this question, first thing we need to understand, this force is vertical net force, we can say vertical F net, and vertical F net at this point, so this is down, so this is vertical F net, and here vertical F net is up, and this is the maximum value. Vertical net force will be maximum at this point and also maximum at this point, and this value is negative because this is pointing down, then this value is positive, but they have the same magnitude. As these two, they have the same magnitude, so we can take point at this point or we can take point here. So this is actually is the bottom, so this is at the bottom F net, and this is at the top F net, and this F net is equal to the centripetal force at the top or at the bottom. So this F net is the centripetal force, so we can simply say FC, this is equal to mr omega square. So we can just read from here. So this is about 0.63 newtons and mass is 9.5 grams. So we can convert this one into kilograms. If you want to write down units, you can also write down the units here, and R we can calculate. Omega we have calculated, that was 39.3 radians per second square. Now if we solve, we will get R is equal to 0.044 meters. R we can say this is 4.4 times 10 to minus 2, and we can multiply this one with 10 to 1, and also we can multiply with 10 to minus 1. Now we can say this is 44 times 10 to minus 3 meters. It means this is equal to 44 millimeters. So diameter, we can say this will be equal to 2 times R, so this will be about 88 millimeters. So it means this is representing diameter, so we can say diameter, so hence it is diameter. So this is how you can answer this question. So diameter is given to us. Part B says the magnitude of the force exerted by the ball on the car was greatest at 0.04 seconds and least at 0.12 seconds. Discuss the position of the car at these two times. You should consider the forces acting on the car. You don't need to do any further calculations. So question is talking about force exerted by the ball on the car. Means question is simply talking about normal reaction force, means normal contact force. And this is telling us it is maximum at this point, means it is maximum at the bottom. We have already discussed. So this is the normal contact force. So this is maximum at this point, and this is minimum at the top, means at this point we have discussed. So this is minimum. But vertical resultant force is the same. Vertical resultant force, so we can say vertical F net. We have discussed a little bit about this one already. This is vertical F net at the top and the bottom. Let me write down at top and bottom. Very important one. You need to understand this one. I have seen some videos as well on this question. Even some teachers online, they are explaining this one in a wrong way. They're not exactly explaining why this is maximum at this point, why it is minimum at this point. They're just saying direction is down and up, so one is positive, negative. That is not right physics. So vertical F net at top and bottom is equal to centripetal force. So this is the point you need to understand. And this graph is not representing FC, centripetal force. Centripetal force is only at this point, and at this point you can find from this graph, because this graph is for vertical F net, and vertical F net is maximum at this point and also maximum at this point. And at this point it is equal to 0. Mean if you say this is centripetal force, it means centripetal force is 0. So it means car cannot go in circle. So this is not centripetal force. This graph is for vertical F net. Now let me explain you a little bit why vertical F net at this point is equal to 0. Because when the car is at this point, there is only horizontal force, and this is the resultant force on the car that is acting in this direction. Means the resultant force at this point on the car is only horizontal. So vertical net force is equal to 0. And it is also true when the car is here, only resultant force on the car is horizontal. There is no resultant vertical force. So that's the reason at this point it is also equal to 0. And so these are the points you need to understand. Now we need to understand the forces at this point and forces at this point. So first of all, I will talk about at top. So we can write down at top. So how many forces are acting on the car? I hope you will say one force on the car is the weight of the car. So we can say this is W of the car. And also there is a normal force on the car. There is a pushing force by the ball on the car. So we can say there is a pushing force, that is N. And in this case, centripetal force is equal to W plus N. W plus N. And this N will be minimum. Now if we talk about at bottom, now we can write down forces acting on the car. Forces acting on the car. So at the bottom there is a normal contact force. So this is normal contact force, mean the ball is pushing car in upward direction, and there is a weight of the ball that is acting down. So this is W. So in this case, centripetal force, this is equal to N minus W. So it means this N will be minimum. So this value of N will be minimum because centripetal force is the same, and this N will be maximum. So these are the points you need to include in your answer. I hope this makes sense to you, this graph makes sense to you, and also you understand the main concepts. Now let me show you the answer, how you can write down your answer for this question. For the answer of this question, we can write down these points. This question has 6 marks and your answer has to be in a logical order, and you can write down these 6 points. First, you can say magnitude of centripetal force is constant. Yes, magnitude of centripetal force is constant. That is, in this graph is not for the centripetal force. Why magnitude of centripetal force is constant? Because this is equal to mv squared divided by r is constant, m is constant, speed is constant. It is given in the question that speed is constant, so it means centripetal force is also constant. So this graph is not for centripetal force because centripetal force is constant, and this is for vertical F net. So this is one point you can say. Centripetal force on car at bottom is here. We have discussed centripetal force is equal to n minus w. When the car is at the bottom, force by the ball on the car is maximum. Centripetal force on car at top is normal contact force plus weight. We have discussed this point. And when the car is at the top, force on car is minimum. At 0.04 second, car is at the bottom, and at 0.12 second, car is at the top, because force on the car at this point is maximum, force on the car at this point is minimum. I hope this question makes sense to you, and I hope this graph is clear to you, this question is clear to you. So if this was helpful, please like and subscribe, and if you need more help and you're looking for extra resources, you're looking for worksheets, you're looking for notes, chapter wise notes, please join Patreon, and link for Patreon is in the description of this video. And also, if you have any questions, leave your questions in comments. I will try to answer as soon as possible. If these videos are helpful, please also share with your friends, with your classmates. They can also get help from these videos, and they can also improve their understanding of physics.